Hello friends, my name is Akash Patel and I am here for sharing some useful knowledge about the software engineering. I hope you are doing good and stay healthy. Let's see. Let's move to the next slides. So let's see the part one introduction of software engineering. So let's see. So what is software engineering? So what software engineering is the process of designing, building, testing, and maintaining software. It helps create a fast, secure, and error-free programs. Also, it's used in apps, websites, games, and also AI. Makes the technology better and easier to use. So this is the software engineering. So why is the software engineering important? So it helps create fast, easy to use and reliable apps and programs. So makes better software. Also save time and money. Fixing problems earlier prevents big mistakes and high cost later. Also grow with more users. Good software can handle more people and data as business expand. Also keeps information safe, protects personal and business data from hackers and cyber threats. Also, its software engineering helps build websites, mobile apps, AI, games, and robots. It's used everywhere. Let's move to the next slides. So, in 1968, NATO held the Software Engineering Conference. So before 1968, making software was slow, it's also costly and full of error. So big projects often fail due to the poor planning. So NATO conference at 1968 and 1969. So, in the NATO conference, experts met to find the better way to develop softwares. They introduced the term software engineering to make software built more structured and reliable. Also, its impacts new methods helps create better, faster, and safer software. So, software development become a serious engineering field. Also its importance. Let's see the today's importance. So thanks to this conference, we now have a stronger tools, teamwork, and security in modern software. Let's move to the next slides. So let's see about the some roles of software engineering in professional software development. So first we can explore, so create high quality softwares. So it's ensure software is fast, reliable, and easy to use. Let's move to the next step is follow a structured process. Use planning, designing, coding, testing, and maintenance to build better software. Also, they make the support team work, helps developer work together efficiently using best practices. Also, it makes software scalable and maintainable. So they ensure software can grow with more users and be easily updated. Also, they improve the security and performance. They protect against the hacker and bugs, making software safe and efficient. So let's move to the next slides. So there is a part two, software engineering versus software programming. So what is the difference between software engineering and software programming? Is this same? Let's see. So software engineering is a they focus on designing and building software systems. So on the other hand, software programmers focus on writing codes to make a specific software features work. Also, software engineers involve planning and analyzing and maintaining software projects. So on the other hand, software programmers involves translating ideas into instructions that computers understands. So next, software engineering ensures software is reliable, scalable, and user-friendly. On the other hand, software programmers deals with the writing, testing, and debugging code. Also, software engineer works with a team to manage big projects and solve complex problems. On the other hand, software programming is one part of the overall software, its engineering process. Let's move to the next slides. So let's see about the key aspects of software engineering. So let's see about the teamwork, complexity, and life cycle management. So let's see the first term, team dynamics. So what is the team dynamics? So team dynamics is how people work together in a software projects. So what's the important of the team dynamics? Good teamwork helps solve problems faster and create better software. Let's see the complexity handling. So complexity handling is means managing difficult and complicated parts of a project, and also it importance for breaking down big problems into smaller one and make them easier to fix. Let's say the long-term software lifecycle management. So it is means taking care of software after it's built, like updates, fix the bugs, and also make the improvements in the software. So why it's important? So it's important because ensure the software keeps working well and stay up to date over time. Let's move to the next slides. So let's see the part three, software processes and development. So let's see about the, okay, so different ways to develop softwares. So first is a waterfall, second is agile and DevOps. So what is the waterfall? It means it is a step-by-step process where each phase like design, coding, testing happens in order. So how it works? So it works once one phase is done, you move to the next. No going back. This is how it's work. And so also it's based for which projects. So that projects with clear fixed requirements. This is the best for that these types of projects. Also, let's move to the agile. What is the agile? So agile is a flexible, iterative approach that focus on small, manageable tasks done in short cycle called sprints. And how agile works? So it works team reviews and adjust work regularly based on feedback. So this is best for that which projects that need quick changes and ongoing improvements. Let's see the DevOps. So what is the DevOps? So DevOps is a combination of software development and IT operations to deliver software faster and more reliable. So how it works? So DevOps works, developers and operations work together automating tasks and monitoring software. So how it works? They works like they working together of the operations. Also, they automating the tasks and monitoring the softwares. So they best for the projects like projects which need continuous delivery and frequent updates. So all these are the way to develop softwares. These are the different ways for the software development. Let's move to the next slides. So key parts of software engineering. We are learning about the key parts of software engineering in these slides. First one is model, then rules, and then design practices. So let's see the first models. So what is the model are? So models are representations and blueprints of how the softwares will work. And what's the important of the models? So it's help plan and visualize the project before building. So let's see the rules. So what uh, what is this means? So there is certain rules, certain guidelines, and standards to follow during development. So why it's important? So that are important because ensure consistency and quality in the software. They ensure that about the consistency and quality of the software. Let's see the design practice. So what is the design practices are? So design practices are methods used to plan how the software will look and function and why it's important. So because it's helped to create software that is easy to use and work well. So these are the key parts of the software engineering. So let's move to the next slides. So there is a part four. So let's see the part four is the software cost and challenges. So let's see. So let's understand the cost of software development and maintenance. In these slides, we are learning about the different types of costs in software engineering. So first one is a development cost. So what's the includes in this development cost? So first one is planning and design. So in the planning and designing, they have to time spent on understanding what the software should do and how it will work. So also this they have to spend on the planning and design. Also, next one is a coding. So they have to spend on time or money, time and money to writing the actual code for the software. Next one is a testing. So they have to check for the bugs or issues in the software and fix them by spending the money. So also last one, let's say the team salaries. So they have to pay the people who are working on the software. So all are includes in development costs. Next one is a maintenance costs. So what is includes in the maintenance cost? So first one is updates and improvements. So adding the new features or making the changes to keep the software useful. So they have to keep for updated of to the software. So next one is bug fixes. They have to resolving problems or errors that come up after release. So they have to fix these bugs. So uh, they have to spend some money on of the fixes of bugs. Next one is a support, helping users with the problems or questions. So they have to make the support teams. They can helping the users with the problems or questions. Also, next one is infrastructure. They have to make the infrastructure for servers and tools to run and maintain the software. So they have to make the infrastructure. So it's costly. It's costly. So all these things are costly. So it's includes in the maintenance cost. So what is the next? Let's see the next slides. So in these slides, we are learn about why maintenance costs can be higher than development costs. So first one is ongoing updates, means software needs regular updates to stay current and improve. So next one is a bug fixes. So it means new problems and errors can appear after the software is released. They have to fix this. So next one we have to see that they have to make the support team so they can help users with the issues or questions, takes times and efforts. So next one is changing needs means as business or technology changes, the software must be adapted. So and next one is the infrastructure. They have made the infrastructure for maintaining the servers and tools to keep the software running smoothly. So all are these factors are these costs are higher than the development cost. So let's move to the next slides. So there is a part five. So we are learning about the professionalisms and ethics in the software engineering in this part. Let's see. So in these slides, we are learning about the ethical dilemmas in the software engineering and their impacts. So first, let's see the ethical dilemmas in software engineering. So first one is privacy concern. Means collecting and using personal data without proper consent can harm users' privacy. So they have to make sure about the user privacy. Then next one is a security risk, means poorly designed software can expose the softwares to hacking or fraud. Then next one is bias algorithm. So it means software can unintentionally favor one group over others, leading to unfair outcome. So next one is intellectual property, means using someone else's code or ideas without permission can lead to legal issues. Also, let's see the next one. So it's last, that's impacts on the job. So it means automation or software can replace the jobs. And then that causes unemployment for some workers. So all are these are the dilemmas, ethical dilemmas in the software engineering. Let's move to the next slides. Okay, so in these slides we are learning about professionalism, code of ethics in software engineering, ACM and IEEE. So what is it? It is a set of rules and guidelines that help software engineers act responsibly and ethically. Next one is ACM and IEEE Code of Ethics is a well-known code that outlines how professionals should behave in the field of computer science and software engineering. So let's see the key principles. So first principle is public interest, means prioritize the well-being and safety of the public. Next one is honesty and integrity, means be truthful and transparent in your work. So next one is a fairness, means treat all users and colleagues equally and fairly. Next one is a respect for privacy, means protect user data and privacy. Also, the next one is not next, last but not least, professional development means continue learning and improving skills. So all these are key principles. So this is the professional code of ethics in the software engineering. They have to uh, behave like this code of ethics. Okay, let's move to the next slides. Okay, so in these slides, we are learning about why professionalism and confidentiality matters in the workplace. So what is the professionalism? So professionalism is acting respectfully, being reliable, and doing your job well. Okay. So why it's important? So it's important because builds trust with colleagues, clients, and employers. It's that's why it's important. It helps you succeed in your career. So let's next topic is confidentiality. So confidentiality is a keeping sensitive information private and secure. And also it's important because protect company secrets, user data, and build the trust. Breaking confidentiality can lead to legal problems and harm the company's reputation. So that's the main factors. There's the two main factors are make your career success. You have to learn this first. Okay, then let's move to the next slides. Okay, if you enjoy the content or found it helpful, give it a thumb up by clicking like. Also, spread the knowledge, share these slides with the friends and colleagues. Okay, by share button, and have a thoughts or questions, drop a comment below. I would love to hear from you. Thank you. Thank you, all of you. I hope you are enjoying this video. Let's stay happy, stay safe. Goodbye.